Okay, let's look at homework 13, problem number 3. Right. So we want to use a double integral to find the volume and under the surface. So this is a surface, and over the region bounded by x plus y equals 0, y equals 0, and y equals square root of x on the xy plane. Right. So let's do that. First, we want to know what the region in the xy plane looks like. So we're gonna do that. Right. So let's sketch this picture. X plus y equals 0. If you don't like the way it looks, we can always rewrite this guy as y equals negative x. Right. So that's just going through the origin. Slope is -1. Right, so we can sketch that. Right, so it's gonna look like this. So let's say, so it's gonna go through -1. Oh, actually I have to put this. So here's -1 comma +1. Right, then it's just a straight line, so I'm gonna just draw a straight line through the origin, so it looks kind of like this. Right. Right, so that's the line here, y equals negative x. Maybe I should, so this is y equals, y equals negative x, right? And also y equals 1, so that's just a horizontal line through 1, so that's easy to draw. So it's going to look something like this, right? So we have that. So this is y equals 1, right? And then y equals square root of x. So that's going to go through 1 comma 1 as well. So I'm going to just draw a dotted line, right? So the graph is going to look kind of like this. So it's a square root of x. So square root of picture looks kind of like this. Right, so this is y equals square root of x. Right, so we have that, and that's just going to be a line like that. All right, so the region we are looking at is going to be right here. So this is the region on the xy plane. All right. So what we want to do is we want to set up the double integral, right? So the volume V is going to be equal to, right? So we have a double integral, right? So the surface is y times quantity x plus 2. So we put that in, y, right, x plus 2. Right, then we have to decide which variable we want to take the derivative first. All right, so looking at this region, looks like if you do it this way, it's going to be we have to split into two separate integrals. But if you fix y and do the x with respect to x first, you can actually do it in one shot. So let's do that. All right, so think of fixing y value. So fixing y value, say somewhere on there, right? So x value goes from this point all the way to that point, right? So we want to do with respect dx first, and we're going to do a dy later, right? So we have to have expression for x values here and x values there, and y values there and y values there. Right? All right, so from here, so beginning is going to be right on this line right here. So we have to write it as x equals. So we just have to rewrite this as x equals negative y, right? So this goes from negative y to, so upper limit would be, so it's gonna up to here, right? So that's right on this y equals square root of x. So we would rewrite it as square both sides. So x is equal to y squared. So this is going to go to y squared, right? So that's just this piece right here. Then what we want to do is we want to cover the entire region. So y is going to start from 0. So that would do that. And increase y all the way up to, so you can see that in order to cover the entire region, you have to go all the way up to 1, right? So y value starts from 0 all the way up to 1, right? Then I'll let you guys evaluate this double integral, right? Right, that's it. I hope that this will get you guys going.